Hello, and welcome to the Student Support Services Program's Workshop Series. The following is an educational recording produced by tutors from the Student Support Services Program at the City College of New York under the supervision of sound engineer, recording engineer, mixing engineer, mastering engineer, producer, arranger, composer, Linwood Fitts. This recording accompanies a PowerPoint presentation by the same name. Please do not post or share these files, which remain the intellectual property of the Student Support Services Program. To begin, open the PowerPoint presentation, and whenever you hear a, turn to the next slide.
Hi everyone, my name is Jiahua Li. I'm a teacher scholar for Student Support Service Program. Today, I'm going to introduce you the rules for derivative in Cal 1. So first, let's look at what's derivative. Derivative can be used in many different fields. For example, in math, physics, and chemistry. What we can see here is the graph going up and going down. So on the top of the maximum point, you can see there's a flag line. So the flag line points indicate the graph going to the maximum point, which means the horizontal line is the maximum point it reached the function.
Can you give more examples about how derivatives are used in real life?
Sure. Derivative can be used in physics. For example, we can find the maximum velocity by taking the derivative of v of x, which is the function of velocity, and the derivative of velocity is the acceleration, as we can see. The v of x is equal 3x plus 6, and the a is equal v prime of x is equal 3. And in chemistry, there's a maximum reaction rates can be attained from the derivative. So now we are going to introduce the first rule, constant rule. Constant rule means we take the derivative of a constant. The derivative of a constant is 0, which means the constant is a flag line in a graph, and the horizontal line meaning there's no change in times. So the changing rate of a constant can be 0. Let's look at an example. Example fx is equal 2 to the 40 power. So what is the derivative of fx? So f prime of x is also meaning the derivative of fx is equal to derivative of a constant, which is 2 to the 40 power. We know that the constant does not change with time or change with any variable. So the derivative of 2 to the 40 power is equal to 0. Okay, we can check about more derivative formula as we talk about here. The derivative formula we use here is xn, sin x, cosine x, tangent x, cotangent x, secant x, cosecant x. There's mainly about polynomial and trigonometric function we need to learn in Cal 1. The second rule I want to talk about is constant multiple rule, which is the derivative of a constant times the function u, which is the derivative is equal constant times the derivative of u. Here, the u stands for the function u of x, a function respect to single variable x. The same terminology we will use for function v of x. As you can see, u of x can be represented as u, v of x can be represented as v. Let's look at an example. Fx is equal 2 divided by 3 times x. So what is the derivative of fx? As we apply the constant multiple rule, f prime of x is equal the derivative of 2 divided by 3x is equal to 2 divided by 3 times the derivative of x, which means the derivative of x is equal to 1. Therefore, the final result is equal to 2 divided by 3. Next, we are going to introduce the sum and difference rule. The sum and difference rules, as you can see here, the derivative of sum and difference can be seen as the sum and difference of derivative of each component. Here, the derivative of u plus v is equal to the derivative of u plus derivative of v. As you can see in the shortcut, is u prime plus v prime. Let's show you the example. For example, ft is equal sin t plus pi times cosine t. So what is the f prime t equal? The function f prime of t is equal to the derivative of a sum, as we can see. So we can first consider the derivative of the first part, which is sin t. So the derivative of sin t is cosine t. And then we can consider the second part. The second part, we are going to use the constant multiple rule. Pi times cosine t, the derivative is equal to pi times cosine derivative of cosine t, which is minus sin t. So the final result will be equal to cosine t minus pi times sin t. Okay, let's look at an exercise. We can have a 1 minute break for doing this exercise. Okay, let's take a look at this exercise. Fx is equal 3x minus 2 times cosine x. So what is f prime of x? F prime of x is equal the individual derivative and then do the subtraction. So we can first look at the first term, 3x. So the derivative of 3x is equal 3 times derivative of x. So it's equal 3 times 1. The second term is 2 times cosine x. The derivative of cosine x is equal minus sin x. So therefore, the final result can be written as 3 plus 2 sin x. Next, I want to introduce power rule. But before I introduce the power rule, I want to review some basic terminology we use here. For example, square root of x can be written as x to the 1/2 power, and cube root of x can be written as x to the 1/3 power. And further, we have fifth root to the x cube can be written as x to the 3 divided by 5 power. In general, n root of x to the m power is equal to x to the m divided by m power. Using this terminology, we can go forward. So what is power rule? Power rule is mean we taking the derivative of x to the n power is equal to n times x to the n minus 1 power. So how can we remember this formula? We can remember the first step, we can move the power n to the front times x, and then we do the subtraction of the power. We get the result. Let's look at an example. The example is fx is equal x to the 5 divided by 3 minus x to the 2 divided by 3. So what is f prime of x? F prime of x is equal the first part, derivative of first part, minus the derivative of second part, as we learned in the sum and difference derivative rule. So the first part is we can move the power in front, which is 5 divided by 3, and we do the subtraction of the power to get the new power number, which is 5 divided by 3 minus 1. We get 2/3 in this case. And for the second term, x to the 2/3, we can do the derivative and move the power in front first is 2 divided by 3, and we do the subtraction and become negative 1/3. So the final result will be 5 divided by 3 times x to the 2/3 minus 2 divided by 3 times x to the negative 1/3. It seems like a little bit complicated. Let's look at an exercise. This exercise we will spend 2 minutes to do this. Okay, let's look at this exercise. Fx is equal square root of x plus x divided by x squared. So what's the derivative of f prime? What's the derivative of fx? So first, we can simplify the function by dividing the numerator by the denominator. What that means is we can use what we discussed in the review section to change the square root to the power notation. Fx is equal x to the 1/2 power plus x. This sums and then we times x to the minus 2 power. So why is x to the minus 2 power? X to the minus 2 power stands for the denominator is to x to the second power. So as we simplify here, is x to the 1/2 times x to the negative 2 plus x times x to the minus 2. And then the final simplification is equal to x to the minus 3 divided by 2 plus x to the minus 1. As we can see here, this is the simplified version of fx. Then we can apply the power rule to solve this problem. F prime of x is equal the first term derivative of first term plus the derivative of second term. In this case, the first term is x to the minus 3 divided by 2. So we first move the power index in front, minus 3 divided by 2, times x to the power subtract 1. In this case, is x to the minus 3 divided by 2 is subtract 1 is equal to x to the minus 5 divided by 2. The second term is x to the minus 1. So derivative of x to the minus 1 is equal to minus 1 times x to the minus 2 power. We can simplify by changing the notation back to the root. Here is negative 3 divided by 2 times square root of x to the 5th subtract 1 divided by x squared. And the final answer is equal 3 divided by negative 3 divided by 2 times x squared times square root of x minus 1 divided by x squared.
Can you explain more about how to get the last step?
Sure. So the last step mainly is about 2 times square root of x to the 5th power. So we recognize x to the 5th power can be written as x to the 2nd power times square root of x. Square root of x to the 4th power we recognize is x to the 2nd power. So therefore, x to the 2nd power times the square root of x is equal to the square root of x to the 5th power. Okay, let's move on. The next rule I want to discuss is power rule. The power rule meaning taking the derivative of a product. So the derivative of a product is taking the derivative of a first component times the same parts of the second component, and then plus the derivative of a second component times the same part of the first component. It seems like complicated. Let's look at an example. This example is g of t equal t to the 3rd power times cosine t. What is the derivative of g of t? So here g of t is expressed as a product. So g prime of t we can consider using product rule. First, we take the derivative of first term, t to the 3rd power, and then times the second term. Then, we take the derivative of second term times the first term. In this case, first term t to the 3rd power, derivative of 3t to the derivative of t to the 3rd power is equal to 3 times t to the 2nd power, which we learned in the power rule before. So we times the same constant, the same second term is 3t to the 2nd power times cosine t. And then we consider the second term. The derivative of second term is minus sine t. Then we times the first term, t to the cube. So the final answer will be 3t to the 3t squared times cosine t plus t cubed times sine t. Let's practice a little bit to get familiar with this rule. This exercise will take about 2 minutes. Okay, let's go over this exercise. H of theta is equal theta times cosecant theta minus cotangent theta. So what's the derivative of h theta? Here, h theta represents as a sum and different rule. Sum and different. So we can use a sum and different rule to deal with h prime of theta. But first, we can apply the product rule to solve the derivative of theta times cosecant theta. So we first take the derivative of first part theta, which is 1, times cosecant theta. Then we consider the second part, which is derivative of cosecant theta is equal to minus cosecant theta squared times the first term, which is theta. Therefore, the results after reusing product rule is cosecant theta minus theta times cosecant squared cosecant theta times cotangent theta. And then we consider cotangent, the derivative of cotangent theta. The derivative of cotangent theta is equal to minus cosecant squared theta. So the final result will be cosecant theta minus theta times cosecant theta times cotangent theta plus cosecant squared theta. Okay, let's look at the number 6 rules I want to introduce. This rule is quotient rule. Quotient rule is similar to what we saw before in the product rule. So the quotient contains the numerator and denominator. So the derivative of a quotient is equal to the derivative of a top times the bottom minus the derivative of bottom times the top. And this subtraction is divided by the bottom square. It looks like this is really difficult formula to remember, but let's look at an example. This example fx is equal square root of x plus x divided by x squared. It looks familiar what we saw before in the exercise. We can use another way to solve this problem by using quotient rule instead of using sum and difference rule. So in this case, we are not going to simplify the fx first. We direct apply the quotient rule formula, which means we are take the derivative for the top times the bottom minus the derivative of bottom times the top. The subtraction is divided by the bottom square. In this case, you can see the derivative of the top is equal to 1/2 times x to the minus 1/2 power plus 1 times the bottom x squared minus the derivative of bottom 2x times the top x to the 1/2 plus x. This result is divided by the bottom, which is x to the 4th power. The result we can get is negative 3 divided by 2 times x to the 3 divided by 2 minus 3 times x squared divided by x to the 4th. This result can be changed as we flip the x to the 4th to the top and become x to the minus 4. And then we do the distribution, which is minus 3 divided by 2 x to the minus 5 divided by 2 minus 3 times x to the minus 2 power. And the final result, we can change back to the root rotation, which is minus 3 divided by 2 times x squared times square root of x minus 1 divided by x squared. So we can do some exercise for this rule to practice more. This exercise will take about 2 minutes. Okay, let's look back this exercise. This exercise is fx is equal cosine x minus 1 minus sine x. It's cosine x divided by 1 minus sine x. So what is the f prime of x? This one we can consider take the derivative of first the top term, which is derivative of cosine x, times the bottom, 1 minus sine x, minus the derivative of the bottom, which is 1 minus sine x, times the top, cosine x, then divided by the square of the bottom. So we get the result minus sine x, which is the derivative of cosine x, times 1 minus sine x, minus cosine x times minus cosine x, which is the derivative of 1 minus sine x. So we simplify the expression is equal to minus sine x plus sine x squared plus cosine x squared divided by 1 minus sine x squared. We know that from trigonometric, sine x squared plus cosine x squared is equal to 1. Therefore, the expression can be further simplified. Is equal to 1 minus sine x divided by 1 minus sine x squared. Divide the top and bottom by 1 minus sine x, we get 1 divided by 1 minus sine x. Okay. Without any problem, let's introduce the last rule I want to talk about. The last rule I want to introduce is chain rule. The chain rule means when you're taking the derivative of one variable, you are going to introduce one more new intermediate variable. You can see when I take the derivative of dy over dx, I can take the derivative of dy over du times the derivative of du divided by dx, which means I can also have the function of x, the function of f, respect to function of g of x, and function of g of x is a function respect to x. If we take the derivative of fg of x, we first consider to take the derivative of f respect to g of x, and then times the result to g prime of x, which is the derivative of g respect to x. Let's look at an example to get familiar with this rule. This example, I show you fx is equal 2 times x to the third power plus 5, and then the whole thing to the fourth power. So we can first assume u of x is equal 2 times x to the third power plus 5, which is the inner part of function. And we take the derivative for the inner part function. U prime of x is equal du over dx equal to 6x squared plus 0. Here, why we get 0? Because the 5 is a constant. As we discussed before, the derivative of a constant is 0. Then we can apply the chain rule for the derivative of fx. Fx is equal, the derivative of fx is equal to u to the fourth power, the derivative of u to the fourth power times the derivative of u. The derivative of u to the fourth power is equal to 4 times u to the third power, which is used the power rule, times u prime. And then we can substitute u of x and u prime of x into fx. Therefore, f prime of x is equal 4 times 2x to the cube plus 5, the whole thing to the third power times 6x squared. And we can simplify this expression. We get 24x squared times 2x cubed plus 5 to the third power. After we discuss this rule, we can do an exercise to practice. This exercise will take 2 minutes to finish. Okay, let's look at this exercise. This exercise is fx equal cosine a to the third power plus x to the third power. We want to find out what is f prime of x. We can first assume u of x is equal a to the third power plus x to the third power. So what's the derivative of u prime? What's the derivative of u of x? The derivative of u of x is equal 0 plus 3 times x squared. So here the constant a to the third power is same we discussed before. The derivative is 0. So fx can be represented as cosine x, cosine u. So f prime of x is equal the derivative of cosine u times the derivative of u respect to x. The derivative of u cosine u is equal to minus sine u, and the derivative of u is equal to 3x squared. We can substitute back the u of x and u prime of x. The final result of f prime of x is equal to minus 3x squared times sine a to the third power plus x to the third power. And here's the result we get from here using chain rule. Okay, any question? Thank you for your coming to this workshop.
This concludes the presentation. Thank you for listening, and we wish you all success in your studies.